Okay guys, so now we'll discuss corollary 2 of the remainder theorem. So for example, let's say we have any polynomial f of x, right? And we want to divide it by ax plus b. Then this corollary says that the remainder of that division would be f of minus b by a. So first let's try to prove that. So our remainder theorem said that when a function fx is divided by x minus a, then the remainder of that will be equal to f of a. That's the remainder theorem. So first let's try to simply prove it in by using this remainder theorem, right? By using the remainder theorem. So ax plus b, we can write it as a times x plus b by a, or we can write it at a times x minus of minus b by a. So now we have an equation of the format a times x minus of minus b by a. So the remainder, as per the remainder theorem, for x minus a, the remainder will be f of a. For x minus of minus b by a, the remainder will be f of minus b by a. So this is a short proof, but we'll try to see the longer version of this proof, right? So fx, suppose any fx, if we divide it by a x plus b, so there will be a quotient, right? So there will be a quotient, so a x plus b times some quotient, so say qx, plus there will be a remainder which is c. So and this remainder will have a degree that is less than the degree of the divisor. So here the divisor is ax plus b, so the degree is equal to 1. So the remainder will have a degree equal to 0. So it's a constant, it's not a function of x. So now let's put f of minus b by a, and let's see whether we get the remainder or not. So we'll put a times minus b by a plus b times qx plus c. So a gets cancelled off, minus b plus b is 0, so 0 times qx is 0, and we find it as c. So f of minus b by a would be the remainder for would be the remainder if fx is divided by ax plus b. So this is the corollary. So now we understood the remainder theorem and its two corollary. So in short, if any polynomial fx is divided by x minus a, then the remainder will be equal to, so I'm just gonna summarize it. So if any fx is divided by x minus a, then the remainder is equals to f of a. So this is the main theorem, and then we have two corollaries. That is, first corollary is one is fx is divided by x plus a or x minus of minus a, then the remainder for that is equals to f of minus a. And the last corollary or corollary 2 is when fx is divided by ax plus b, then the remainder is equals to f of minus b by a. So remainder theorem, and we have, this is the main remainder theorem, and we have two corollaries. So now let's solve a few examples to solidify the concept of remainder theorem. Okay, so let's look at the first example. It says when ax cube plus 3x square minus ax plus 4 is divided by x minus 2, the remainder is a. So we know the remainder when a polynomial is divided by x minus a, which is equals to f of a. So when a polynomial is divided by x minus 2, the remainder would be f of 2, right? So fx here fx is given as x cube plus 3x square minus ax plus 4. So that is the fx. We know the remainder when divided by x minus 2, this remainder will be equals to f of 2, and now that is given as a. We need to find the value of a. So let's substitute the value. Let's find f of 2. So x cube is 8, 2 cube 8 plus 3 times 2 square is 4, 4 times 3 is 12 minus a times 2, that is minus 2a plus 4, and this entire value is equals to a. Or we get 12 plus 8 is 20, 20 plus 4 is 24. So 24 in minus 2a, if we move it to the other side, then we get 3a. Or if we add 2a on both sides, we get 3a, or a is equals to 24 by 3, that is 8. So using the remainder theorem, we can easily solve this question and find the value of a. I hope this is clear to you. So we'll move on to our next example. In this example, it is asked to find the remainder of this polynomial, that is 3x cube plus 5x square minus 11x minus 4. So fx is given as this, and we have to divide this by 3x plus 1. So it is in the form of ax plus b. We know that when a polynomial is divided by ax plus b, then the remainder would be f of minus b by a, f of minus b by a for ax plus b. In this case, b is 1 and a is 3. So f of minus 1 by 3 will be the remainder when it is divided by this. So the remainder will be f of minus 3 when it is divided by 3x plus 1. So all we need to do is to find the remainder. So it's an easy question. So f of minus 1 by 3, and that is the answer, is equals to 3 times. So minus 1 by 3 whole cube is minus 1 by 27. So 1 by 27, we have a negative sign, plus we have 5 and x square. So minus 1 by 3 whole square is plus 1 by 9. So plus 5 by 9 minus 11x. So minus of minus 1 by 3. So plus 11 by 3, and we have a minus 4, right? So here 3 and 9, then we'll take the denominator as 9. So here we get a minus 1. Here we get plus 5, plus we get 11 times 3 is 33 minus 9 times 4, that is 36. So 33 plus 5 is 38 minus 36 minus 1, 37. 38 minus 37, that is 1. So it's coming to 1 over 9. So final answer is 1 over 9. That is the remainder without actual division. We can easily find the remainder, right, using the remainder theorem. Okay, I hope again this question is clear to you guys, and we'll move on to our next example. Okay, so in this example it is said that what number should be added to this polynomial so that the resulting polynomial leaves a remainder of 10 when divided by 2x plus 1. So we have to add some number. So let that number, so let the required number be k. So the polynomial after adding k is equals to 2x cube minus 3x square minus 8x plus k. So we want to add k to this polynomial such that when it is divided by 2x plus 1, so we want to divide it by 2x plus 1, the remainder will be equal to 10. So what do we know? If a polynomial is divided by 2x plus 1, what is the remainder? So the remainder will be f of minus 1 by 2 minus b by a. B is 1, so 1, a is 2, so minus half, and that is given as 10. So from this equation there will be only one unknown, that is k, and we can easily find the value of k. So let's solve it. So f of minus 1 by 2, let's find that. So 2 times minus 1 by 2 whole cube is minus 1 by 8. So 2 times 1 by 8, and we have a negative sign, minus 3 times x square. So minus 3 times x square is minus half square is plus 1 by 4. So minus 3 by 4 minus 8, and x is minus half. So minus times minus is a plus, and 8 by 2, that should be a 4 plus k, and this value is equal to 10. So next step we'll write it as 10. 2 and x is 4, so let's take 4 as the denominator. We have minus 1, we have minus 3, and we have 4. So 4 times 4 is 16, so plus 16, plus we have 4k, that is equal to 10. So 16 minus 4, that is 12, and we have 40. 40 minus 12, that is equal to 4k, or 4k is equals to 28, or k equals to 7. So using the concept of remainder theorem, we can easily find the solution for this question. Okay, I hope this is clear to you guys. So now we'll move on to our next segment, that is okay, before that we have another problem that we want to solve. So let's solve this one. The polynomial ax cube minus 7x square plus 7x minus 2, and another polynomial, that is x cube minus 2ax plus 8x minus 8, when divided by x minus 2 leaves the same remainder. So we need to find the value of a. So what is given? So suppose first one is fx, so let's put this as fx, and let's consider this as gx. So what is told, that the remainder when divided by x minus 2, so remainder will be f of 2 for the first function and g of 2 for the second function. So it is said that f of 2 is equal to g of 2. So find the value of a. So if we substitute 2 on in the first equation, or in the first function, so a times 2 cube, we'll write it a times 2 cube minus 7 times 2 square plus 7 times 2 minus 2, and that is equal to 2 cube minus 2 times a times 2 plus 8 times 2 minus 8. So from here we get 8a, 2 cube is 8, so 8a minus 2 square is 4, 4 times 7 is 28, plus 7 times 2 is 14, minus 2, that's equals to 2 cube, that's 8, minus 2 times 2 is 4, so 4a, plus 8 times 2 is 16, minus 8. 8 and 8 gets cancelled, and here we have, so we have minus 28 minus 2, that is minus 30, minus 30 plus 14. So 30 is 14 plus 16 is 30, so 30 minus 30 plus 14 is minus 16. So 8a minus 16 is equals to minus 4a plus 16. So 8 plus 4, that is 12a, is equals to 32, and a is equals to 32 divided by 12. So 4 times 3 is 12, 4 times 8 is 32, so final value of 8 is 8 over 3. That's the final value of a. So through these examples, we have solved a few questions on the application of remainder theorem. I hope with this illustrative example the remainder theorem is clear to you guys. So now we'll move on to our next segment, that is the factor theorem. So factor theorem is very similar to remainder theorem in that it is said that if fx is a polynomial and a is a real number, then x minus a is a factor of fx if a is if fa equal to 0. In the remainder theorem, what we said is that if a polynomial is divided by, so say if a polynomial fx is divided by x minus a, then we said that the remainder equal to f of a. That's what we said. So suppose it said that here, suppose if fa would have been equal to 0, so the remainder would be equal to 0. That would mean that x minus a was a factor of fx, right? So this is basically using the remainder theorem concept. What is the remainder theorem concept? That when fx is divided by x minus a, then the remainder is equal to fa. Now we are said in the factor theorem that if fa equal to 0 or if the remainder equal to 0, then we would say that x minus a is a factor of fx, right? So that's the same thing that this factor theorem is saying. So if fa equal to 0, then x minus a is a factor of this polynomial fx, right? And the proof is by using the remainder theorem, right? When fx is divided by x minus a, then the remainder equal to fa. Now x minus a is a factor if the remainder is 0, and if fa equal to 0, then x minus a is a factor of fx, right? So I hope this is clear to you guys, and this is well written also here. So we'll move forward to the 3 corollary, and again it's very similar to the corollary of remainder theorem. So if a polynomial, if fx is a polynomial and here it should be a is a real number, then x plus a is a factor of fx if f of minus a equal to 0. Same thing, right? If so in the remainder theorem what we learned is if we divide a polynomial by x plus a, then the remainder equals to f of minus a, and if that remainder equal to 0, f of minus a equal to 0, then x plus a must be a factor of fx, and that's what it is written in the corollary. Second corollary is also very similar to the second corollary of the remainder theorem, that if fx is a polynomial a not equal to 0 and b, so a and b are real number, then ax plus b is a factor of fx if f of minus b by a equal to 0. So again we know that if we divide fx by ax plus b, then the remainder equals to f of minus b by a, and if this remainder is equal to 0, so obviously ax plus b is a factor of fx. So these two corollary are very similar to that of the remainder theorem. So this can be very similar to the remainder theorem, and it is actually derived from the remainder theorem. So this factor theorem and corollary are derived from the remainder theorem. So now let's look at corollary 3. If fx is a polynomial and a is a real number, then x minus a is a factor of fx if a is a root of the equation fx is equals to 0. So a is the root of the equation means if we plug in f of a, then the equation will give a value of 0. So it's a very same concept, it's just worded differently. So we know by factor theorem x minus a is a factor of fx if f of a is 0. So then we can say that a is the root of the equation. So what is the root of the equation? If we plug that value into the equation, the resultant will be 0. So that value is the root of the equation. So if x minus a yields a remainder of 0, then that a is the root of the equation. So x minus a is a factor of fx and a is the root of the equation fx is equals to 0. Okay, so I hope the corollary and the all the corollaries and the factor theorem is clear. It's very similar and uses the concept of the remainder theorem, right? So now we have come to the end of the theories involved in this chapter. So now what we'll do is we'll solve more illustrative examples in order to make the concept more clear, right? So let's tackle this question. What number should be added to this function so that the resulting polynomial leaves the remainder 10 when divided by 2x plus 1? So we did a very similar question before, so we'll just assume the number to be, so this is question 5. So if we write answer 5, we'll say let the number to be added be k, right? So we are assuming the number to be k. So this function becomes fx is equals to 2x cube minus 3x square minus 8x plus k. So this is the new polynomial equation, and what is said that if we divide this polynomial by 2x plus 1, then the remainder is equals to 10. So what is the remainder when we divide a polynomial by ax plus b? The remainder is minus b by a. So the remainder for this situation would be f of minus 1 by 2, right? So this should be the remainder. So let's put the, so we'll substitute f of, I think this is the same question that we did, so I'm just going to skip it because it's actually the same question. So we'll move to our next question, right? Okay, show that x minus 5 and 2x minus 1 are factors of this. So what do we know? That if the remainder of, so how can we say that this is a factor? So if we plug in f of 5 should be equal to 0, and if we plug in f of 1 by 2 should yield a value of 0. So if this happens, then we can conclude that these two numbers are factors of 2x square minus 11x plus 5. So let's check. So 2x square minus 11x plus 5. So let's plug in 5. So 2 times x square is 25 minus 11 times 5 plus 5. So 25 2s are 50. 50 minus 11 5s are 55 plus 5. So 50 plus 5 is 55 minus 55. So it gives a value of 0. So f of x is this. So f of 5 is this. So f of 5 equals to 0. Therefore 5 is a root of fx, or we can say that x minus 5 is a factor of fx, right? So we can conclude that. Next we'll check it for f of half. So what is f of half? F of half, if we write it here, so 2, so here I'll draw a line. So 2 times half square, so 2 times 1 by 4 minus 11 by 2 plus 5. So 2 and 2, so we'll take here, we'll take 2 as the common factor. So 1 minus 11 plus 5 times 2 is 10. So 10 plus 1 11 minus 11, that is 0. So again f of minus half. So f of minus f of half is equals to 0. So from here we can conclude that so half is root of fx, is a root of fx, right? Is a root of fx, and x minus half is a factor of fx, right? Okay, so I hope this example is also clear to you guys. So let's move on to the next question. Okay, so let's look at example number 7. So use factor theorem to factorize this expression. So fx is given as x cube plus x square minus 4x minus 4. Now we need to use the factor theorem. So what is the factor theorem? Factor theorem says that if x plus alpha is a factor of any function fx, then f of alpha would be equal to 0, right? That's the factor theorem. So we need to find an alpha for which this value would be equal to 0. So let's use trial and error initially. So we see that if we put it as 1, so 1 plus 1 is 2 minus 8, so that definitely won't be 0. So let's try with 2. So 2 cube is 8, 8 plus 4 is 12, minus 4 2s are 8, minus 4 12. So we can see 2 is a factor. So f2, if we put 2 cube is 8 plus 2 square is 4, minus 4 2s are 8, minus 4, so that becomes 0. That means 2 is a root of fx and x minus 2 is a factor of fx. Is that clear? So if that is so, then we can get the remaining part of this equation by dividing this fx by x plus 2. So let's do the division. So sorry, x minus 2 divided by x cube minus plus x square minus 4x minus 4. So first let's multiply x minus 2 with x square to get x cube. So multiply this with x square, we get x cube minus 2x square. So if I subtract it, so we get 3x square minus 4x minus 4. So multiply this with 3x now, so we get 3x square minus 3 times 2, so 6x. Again we subtract, so we get, so plus 6x minus 4x give us 2x minus 4. So x minus 2, so if I multiply x minus 2 with 2, we get 2x minus 4. So we can write it as, so we can write this function fx is equals to x minus 2 times x square plus 3x plus 2, and we can further factorize this one using simple factorization, that is x square plus x plus 2x plus 2. We can write it in this way. So further we can simplify it as that x times x plus 1 plus 2 times x plus 1. So finally it is x minus 2 times x plus 2 times x plus 1. So using the factor theorem we completely factorize this equation. Hope that is clear to you. So we'll move on to our next question. Question number 8. What number should be subtracted from this equation or this function? We can put it as fx. So what number should be subtracted from fx so that the resulting polynomial has a factor to x minus 3? So some number has to be subtracted, so let the number be k. So let the number to be subtracted b k. So the function becomes fx is equals to 2x cube minus 5x square plus 5x minus k, since k needs to be subtracted. Now the resulting polynomial has a factor of 2x minus 3. So if the polynomial has a factor of 2x minus 3, so f of minus b by a, or minus of minus 3, so plus 3 by 2 must be equal to 0 as per the factor theorem, right? So we can substitute 3 by 2 in place of x and find the value of k. So 2 times 3 by 2 whole cube, so 3 cube is 27 divided by 2 cube is 8, minus 5 times x square, so 9 by 4 plus 5 times x, that is 3 by 2 minus k, and this must be equal to 0, right? So 0 equals to this, so we'll take 8 as the common denominator. 2 times 27 is 54, minus 5 times 9 is 45, and times 2, since the denominator here is 4, so 45 times 2 is 90, so minus 90, plus we have 5 times 3 is 15, 15 times 4, right? So that is 60 minus k, or this k must be equal to so 60 plus 54, that is 114 minus 90, so k must be equal to 24. So that is the answer. So using the factor theorem, we could easily find the answer of this question, right? So what did we do? We took this function as fx, and then it is said that some number has to be subtracted, so we assumed that number to be k. Now we wrote the function as this given minus k, and now since it is said that this polynomial has a factor of 2x minus 3, from the factor theorem we know that f of minus b by a, or 3 by 2, would be equal to 0. So when we substitute that, there was only one variable that was left, that was k, and we found the value of k, right? Hope this is also clear. So we'll move on to our next example, and this is going to be the last example that we are going to do on factorization. X is equals to 2x cube plus x square plus, my apologies, it should be bx, not ba, minus 2 has a factor of x plus 2. So whenever it is said that this polynomial has a factor of x plus 2, immediately using the factor theorem we can say that f of minus 2 must be equal to 0. So we'll write it like that, and leaves the remainder of 7 when divided by 2x minus 3. So when this polynomial is divided by 2x minus 3, then the remainder is what? F of, so when a polynomial is divided by ax plus b, the remainder would be f of minus b by a, so minus of minus 3 by 2, or f of 3 by 2 would be the remainder, and that is given as 7. So we are given these two equations, f of minus 2 equal to 0 and f of 3 by 2 equal to 7. With these values we have to find the values of a and b, so we'll get two equations, so we can find the value of a and b using these two equations. And what else is asked? With these values of a and b, factorize the given polynomial completely. So we have two tasks. First is to find the value of a and b, and second, after finding the value of a and b, we are required to factorize the polynomial. So let's do step 1. F of minus 2 equal to 0. So let's plug in the value of minus 2 in place of x, and then equate it to 0. So 2 times minus 2 cube is minus 8, so 2 times minus 8 plus a times x square. So what is x square? Minus 2 whole square, that is plus 4, right? Plus b times x, or b times minus 2, so plus b times minus 2, right? And minus 2. that is given as 0. So from here we can write minus 16 plus 4a minus 2b minus 2 equals to 0, or 4a minus 2b minus 18 equal to 0, or we can write it as 4a minus 2b is equals to, so minus 18 will bring it on the other side, so plus 18. So first equation we get it as 4a minus 2b equals to 18. Now let's use this equation, f of 3 by 2 equals to 7. So 2 times 3 by 2 whole cube, so 3 cube is 27 and 2 cube is 8. So 2 times this plus a times x square is 9 by 4, so 3 by 2 whole square is 9 by 4, plus bx, so b is constant and x is 3 by 2, so b times 3 by 2 minus 2, and this entire thing is equal to 7, that is given. So what we'll do is we'll take a common denominator as 4, right? So we take the denominator as 4, 7, and finally we'll multiply 7 with 4, right? So what we have here is 27 plus 9a, denominator is same, denominator is 2, so we have to multiply 3b times 2, so plus 6b, and we have minus 2 times 4, so minus 8, right, equal to 7. So what we'll do is we'll multiply 7, so we'll remove the 4 from here and we'll multiply that with 7, so 7 times 4 equals to 28, right? And 27 minus 8, that is 19, so 9a plus 6b, that is equals to 28 minus 19, so 28 minus 19 will give you 9, right? So 9a plus 6b equals to 9. From this equation we have 4a minus 2b equals to 18. So what we'll do is, this is equation 2, so 1 times 2, so what we'll do, 1 times 3 plus 2, this is what we are going to do. So 1 times 3, so 4 times 3 is 12a, minus 2 times 3 is minus 6b, equals to 18 times 3 is 54, right? So 6b cancels out, and 21a is equals to 63, or a equals to 3. So if a is equals to 3, then 4 times 3, that is 12, so 12 minus 18 would be equals to 2b, or 2b is equals to minus 6, or b is equals to minus 3. So finally our polynomial becomes fx is equals to, we'll plug in the value of a and b in this polynomial, so 2x cube plus ax square, so a is 3, so plus 3x square plus bx, so b is minus 3, so we'll have a minus 3x and minus 2. So that is the given polynomial. Now let's move on to step 2. Step 2, it is asked to factorize the given polynomial. So what do we know? We know that one of the factor is x plus 2. So let's divide this polynomial with x plus 2 and see what we get as the quotient. So now our next task would be to divide this by x plus 2. So that's what we are going to do. So that's what we are going to do. So 2x plus 2, and let's divide 2x cube plus 3x square minus 3x minus 2. So first we multiply with 2x square, so 2x square times x is 2x cube, minus 2 times 2x square is plus 4x square, so subtracted, this gets cancelled, minus 4x square plus 3, so minus x square minus 3x minus 2, right? So now we have to multiply this with minus x. So minus x times x minus x square plus 2 times minus x minus 2x. We subtract it, so this is negative, this becomes positive, both of them become positive, this cancels out, minus x and minus 2, so times minus 1, so minus x minus 2, and it cancels out. So finally we can write it in the form of, so fx can be written as x plus 2 times 2x square minus x minus 1. So now we can further simplify this. How can we do that? So x plus 2, we know that b is equals to a times c, so 2 times 1, so 2x square minus 2x plus x minus 1, we can write it in this format, equals to x plus 2 times, let's take 2x as common, so x minus 1, so x minus 1, and here let's take 1 common, x minus 1. So finally x plus 2 times 2x plus 1 times x minus 1. So this is the complete factorized form of the given polynomial. So that was the last question. Thank you very much for your attention. I hope you liked the session. If you have any question, please write back to us and we'll try our best to resolve your queries. Once again, thank you very much for listening.